Hello, class. We're about to start section 4.5, an average Joe, and we're on page 447. Our learning objectives is to compute measures of average for given data, to interpret the story told by measures of average, to compute and interpret the mean for group data, compute weighted grades, and use technology to compute measures of average. The average dog is a nicer person than the average person. Andy Rooney. Are you an average college student? What does that even mean? According to a variety of sources found on the web, the average college student is 20 years old, lives on campus, and works off campus during the school year. She is female, talks to her parents every day, and comes from a family with an annual income between $50,000 and $100,000. She sleeps 6 hours a night, has $2,700 in credit card debt, and will leave college with $21,000 in total debt. If this doesn't sound exactly like anyone you know, don't feel bad. As we will learn in this lesson, the word average is ambiguous. There are a variety of ways to describe an average. So what one source considers average might not match someone else's thoughts. And with so many different facets to a person, it's possible that nobody exactly meets all of the average criteria. Okay, now it says here, our goal in this lesson will be to understand the different measures of average. In casual terms, average means the most typical case, or the center of where the values in a data set are distributed. In this lesson, we'll study four different ways of measuring average: mean, median, mode, and mid-range. Let's suppose that an individual, let's just call him George, is about to finish college and step out into the workforce. George finds a small company, Vandelay Industries, which he's considering going to work for. While researching this company, George finds a flyer on which that company advertises that its average employee makes almost $150,000 per year. This sounds pretty darn good to George, so he accepts an entry level position at a low salary, betting on a quick advancement to that alleged average. Shortly after starting his career, while emptying the recycling bin in the copy room, just one of George's glamorous duties, he stumbles across a list of salaries for all employees at his new company. Let's investigate just how true the company's average salary claim is. Here's the salary list for Vandelay Industries, which we'll use to study measures of average, which are more technically called measures of central tendency. Now we look here at the employee names, and we also have their salaries listed as well. Okay, now it says the mean. There's a pretty good chance that when you think of average in a math class, what you're thinking of is actually called the mean. The mean, also known as the arithmetic average, is found by adding the values of the data and dividing by the total number of values. Here's a good way to think of the mean. If all of the numbers were equal weights put on a number line, the mean is where the number line could be balanced without tipping in one direction or the other. The Greek letter sigma is used to represent the sum of a list of numbers. If we use the letter x to represent data values, the sum or sigma of x means to find the sum of all values in a data set. Using this notation, we could write a formula for finding the mean. So basically, the formula for finding the mean is to add up all the values and divide by how many values you have. And remember, the symbol, this x bar, this is actually the symbol for the mean. Now it says find the mean salary for the company. Now what I'm going to do, I'm going to show you how to find the mean by hand, and then I'm also going to show you how to find it on the calculator. So the mean value, if we look back up here at these salaries, we have 58,000. Well, first of all, we'll do the mean is equal to, we have 58,000 plus 65,000 plus 944,000 plus 20,000 plus 52,000 plus 51,000 plus 53,000 plus 55,000 plus 50,000. And that's all divided by, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 salaries here. So this would be all divided by 9. So remember how I told you. You add up all the values and divide by how many values you have. So the mean is equal to, so if we add up all of these values, let's see, we have 58,000 plus 65,000 plus 944,000 plus 20,000 plus 52,000 plus 51,000 plus 53,000 plus 55,000 plus 50,000. So that gives you a total of 1,348,000 divided by 9. So that would give us approximately $149,777 and about 78 cents. So that is the mean salary. Now, even though we had 9 numbers, that took a little while to do. So what I'm going to do now, I'm going to show you how to put this in the calculator. So what we would do here, we would go to the calculator and add a table. Now with our table, we cannot put the names in the table, so we would just put their salaries. So we have 58,000. Then we have 65,000. 944,000. 20,000. 52,000. 51,000. 53,000. 55,000. And 50,000. Okay, now we know that we have 9 elements here. Now, what you need to do is click function, and then you will go here to stat, you will click on stat, and then you will click mean. And then we look here, all of these values are in X1, so we would type in X1, and it gives us the mean. So that's how you would get the mean using the calculator. All right. Now we go down here to problem number 2. It says Newman owns the company and obviously pays himself a handsome salary. If we ignore Newman's salary, what is the new mean? Based on this, do you feel like the mean is a good measure of what the typical employee makes? Okay, listen. Instead of us writing out all of these values here, what I'm going to do with this calculator, we know when we added up our numerator, it was 1,348,000. Then we're going to subtract out Newman's salary, which was 944,000. So that would give us 404,000 divided by, it'll be 8 now because we took out 1 salary. So what we would do, the mean here without Newman's salary would give us 404,000 divided by 8. And then I'm going to show what we did. We took this 1,348,000 minus the 944,000 and divided by 9 minus 1 because we took out the 1 salary. And it gave us this 404,000 divided by 8. which our mean would be approximately 50,500. Well, actually, it's actually exact. So actually, without Newman's salary, which was quite high, the average is actually $50,500. Okay, and then it also asks us, based on this, do you feel like the mean is a good measure of what the typical employee makes? And I would say no, because Newman's large salary inflates the average by almost $100,000. It inflates the average by almost $100,000. Now that is a big inflation. Okay, now we go on here to the next page. It says the median. According to the national, oh, one other thing. To show this too, what you could do here to get it on the calculator, if we go here and take out the 944,000, your mean will automatically update. Okay, so just to show you that in the calculator as well. All right, the median. According to the National Organization of Realtors, the mean selling price for existing homes nationally in August 2015 was $271,600. The median selling price, on the other hand, was $228,700. Since both of these are measures of central tendencies, how can they be so far apart? What exactly is the median? In this case, the median tells us that half of all homes sold during this month were priced above $228,700 and half were priced below that amount. In short, the median of a data set is the value in the middle if all values are arranged in order. The median will either be a specific data value in the set or will fall in between two values. Here's how we find a median. Arrange all the salaries at Vandelay Industries in order from smallest to largest. Okay, so let me put this back here at 944,000. This is so we don't have to keep going back and looking. So we want to arrange this from the smallest salary to the largest salary. So 20,000 is the smallest. And then the next smallest will be the 50,000. So far we got 20, we got 50. Then the next would be 51,000. The next would be 52,000. And then 53,000. And then 55,000. 58,000. 65,000. And then finally the 944,000. That's a range from the smallest to the largest. Okay, now it says find the salary that's right in the middle of your ordered list. That's the median salary. How does it compare to the mean? So if we look here, the median salary, this the middle of the 9 values would be this 53,000. So we'll say the median is equal to 53,000. And how does this compare? This is way less than the mean salary of $149,700. $777.78. That's way less than that. If there is an even number of values in the data set, there will be two values in the middle, not one like in question 4. How do you think you find the median in that case? Basically, you would add the middle two values and divide by 2. That's what you would have to do in order to solve when it has an even amount of numbers. Now, we move on to the next page. It says, finding the median of the data set. It says, step 1, arrange the data in order from smallest to largest. And then step 2, the way we find the median depends on whether the number of data values is even or odd. When it's odd, you just pick the number that's in the middle. When it's even, you will add the middle two numbers and divide by 2. Okay, number 6. It says, find the median of the salaries at Vandelay Industries without Newman's. How does it compare to the median of the salaries with Newman's included? Okay, now, one other thing that I didn't show you, let me go back here. We found the median by hand, but now we can also find the median using the calculator. You go to functions and stat, where you see median here, you could type in X1, and it gave us 53,000. Now they ask us to find the median of the salaries without Newman's. So basically, we'll be putting all these values in, the 20,000, the 50,000, 51,000, 52,000, 53,000, 55,000, 58,000, and then 65,000. Okay, now taking what we know, since there's only 8 values here, the two numbers that's in the middle, and how you could tell that is this here. You have 3 values in front of these two numbers and 3 values behind it. So these are the two numbers that's in the middle. So then you would add these two together. So the median, we'll take the 52,000 plus the 53,000 and divide them by 2. So this would give us 105,000 divided by 2. With 105,000, that'll be 52,500. That will be your median. Now, of course, here, if we just took out this 944,000, the median will automatically update, which is 52.5. So that's how you would get the median using the calculator. Now, number 7. What does this tell you about median when there are outliers, sample data values that are very far away from the majority of values? This is a very key idea, so give it some thought. So basically, median is not affected much by an outlier like the mean is. That's what it basically tells us. Now it says find the median of salaries at Vandelay Industries without Newman's if Kramer quits to start his own company. Now I'm not going to write all of those numbers over again, but we're going to look back here at Kramer's salary. Kramer's salary is $65,000. So what I would do, I would go back to this table and also take out the 65,000. So Newman's and Kramer's is out, and then it gives us the median of 52,000. So the median will equal 52,000 Or we could, just to show you, since we wrote it out here, if we took this out, then it would just be 7 values, and the middle value would be this 52,000. Okay, so it says, what can you observe? The median is still not affected much by removing Kramer's salary. All right. Now we move on to our next page. Now we come to page 451. The mid-range is another measure of average. The advantage of the mid-range is that it's very quick and easy to calculate. The disadvantage is that it totally ignores most of the data values. So it's not a particularly reliable measure, but in a pinch, it can give you a rough idea of average. Number 9, find the number halfway between the lowest and highest salary in Vandelay Industries, including Newman's. That's the mid-range. Okay, so it's the number halfway between the lowest and the highest salary. So what you would do, you would list out the lowest salary, which happens to be 20,000, and then the highest salary, which is Newman, 944,000. Now, what you would do, because it says it's halfway between, you would add these two values, the 20,000 and the 944,000, and divide it by 2. And when you divide these by 2, it'll give you 482,000. Now, we do have this definition here where it says find the mid-range of a data set. It says find the smallest and largest values in the data set. Find the mean of these two values. Number 10, find the mid-range of the salaries at Vandelay Industries, excluding Newman's. How does it compare to the mid-range of all salaries? All right. Well, it said excluding Newman's. So that would mean that Kramer's would be the highest at 65,000. So we know the lowest would still be 20,000. The highest now would be 65,000. So now we would take this mid-range. We'll take our 20,000 plus our 65,000 divided by 2. So this would be 85,000 divided by 2, which is $42,500. So basically, it is what? Over 10 times smaller? It is over 10 times smaller without Newman's salary. Now it says, number 11, explain why the mid-range isn't very reliable as a measure of central tendency. And it's basically what was stated earlier. It ignores all values except the highest and lowest value. All right. Now we come here to problem number 12 on the next page, page 452. It says the mode. The fourth measure of average is called the mode. The mode is sometimes said to be the most typical case. These data represent the duration in days of the final 20 U.S. space shuttle voyages. Which number of days appears most often on the list? That's the mode. Okay, if we look here, it looks as though 12 appears the most. 12 appears 2, 4, 6, 7 times. None of the other numbers appear that many times. So it's 12. So the mode is 12. Okay, number 13. It says, how does the mode compare to the mean? What do you think describes the typical case best? Now, with this mean, we'll need to add up all of these numbers and divide them by 20. So we could just put this in here, 11. Well, let me go back here. We can do it in our typical fashion. 11 plus 12 plus 13 plus 12 plus 15 plus 12 plus 15 plus 13 plus 15 plus 12 plus 12 plus 15 plus 13 plus 10 plus 13, plus 15 plus 11 plus 12 plus 15 plus 12. And we divide all of that by 20. And it'll give us 12.9. So the mean is 12.9. And then we would, it says, which do you think describes the typical case best? Now, of course, they're asking you basically your opinion. So for me, I would think the median would describe the typical case best because it is not easily manipulated like the rest. It says the mode is the value that occurs most often in the data set. Now, one thing, if we look here, well, let me see if we have some of these cases before I tell you about this case. It says a data set can have more than one mode. If two or more values are tied for most appearances, or no mode at all if every value appears only once. While modes aren't extremely useful for small data sets with numerical data, we'll begin there to help get an understanding of what the mode is about. The number of wins in each 16-game season for the Cincinnati Bengals from 1996 to 2018 is listed below. Find the mode. Now, if you look here, the mode is going to be two of them. It's going to be 8 and 4. Now, if you count here, there are 4 8s and 4 4s. None of the other numbers appear that much. So the mode is 4 and 8. Now 15, how does the mode compare to the mean? Discuss again, include a description of which measure of central tendency you think is more reliable in general and why. You might consider the fact that there might not be a single answer. It could depend on what you want to learn from the measure of average. Okay, now we already know how to do the mean, so I'm just going to state what the mean actually is. And I'm going to use the symbol. The mean is approximately 7.2. That would be the mean. So they're asking us which one we think is best in this situation. I would say that the mean is better because the mode having two answers does not help. Because what are you going to do with 4 and 8 if you're trying to find a measure of central tendency? You got two different answers. Whereas with the mean, you have one answer. You're able to do something with the one answer, but with two answers, you won't be able to do anything. All right. Now we move on to the next page. So we have problem 16. Do the employee salaries at Vandelay Industries have a mode? We would say no. And the reason being, all salaries appear only once. The mode is probably most useful when data are classified by groups or categories. In fact, it's the only measure of central tendencies that even makes sense when the data values aren't numbers. For the average college student, at the beginning of the lesson, I challenge you to find the mean of male-female. A survey of the junior class at Fiesta State University shows the following numbers of students majoring in each field. Find the mode. Now remember, the mode is a number or numbers that appears the most. And here we have our majors and we have the number of people in that major. So we look for the highest number. So that's the one that would appear the most. So your mode is actually business. Your mode is business. So you could say the mode is business majors. Now 18. Now let's evaluate the average salary claim made by Vandalay Industries at the beginning of this lesson. How truthful do you think that claim was? Use the measures of average you found in the lesson to discuss whether or not you think they were being deceptive in any way. I'm not going to say that this question is the main point of the entire lesson, but it is. Okay, basically, mathematically, Vandelay Industries was correct. But practically, it is misleading. By counting the owner's salary, which no one else will make, this causes an inflated average. Median would be the better measurement. So median would be the better measurement. Okay, now we go over here to the back. We're mainly going to look here at finding the mean of group data. And what's interesting here is it's in the solved example 1 section. It says finding the mean for group data. Here's another look at the group frequency distribution for the record high temperature in each state from lesson 4.4. Find the mean of these high temperatures. Solution. The strategy is based on this idea. If we have a group frequency distribution and don't know all of the exact values, it's impossible to add up all the values. Instead, we'll find the midpoint of each class and estimate that all of the values in that group would likely average to that midpoint. In this case, by average, we mean mean. So if we multiply the number of values in a class by its midpoint, we're estimating the sum of all values in that class. First, we'll need to find the midpoint of each class in the group data. To make it easier, you can find the midpoint of the first class, then just keep adding the class width to find the others. In this case, the first midpoint is 102, and the others are 107, 112, 117, 122, 127, and 132. Now, what I'm going to do, because for some reason, I don't know why they didn't do this, but I'm going to carve out the midpoint here. Just so you could get a visual representation of the midpoint. So basically, you get the midpoint. If you add these two and divide by 2, that will give you the midpoint. So this is 102. And if you notice here, the class width is going up by 5s. So we would add 5 to each one. And these will be our midpoints, which was stated earlier. Now it says here, next, multiply the number of values in each class by the midpoint. So basically, they want you to take the frequency and multiply it by the respective midpoints. So when you do that, you add 3 times 102, which will give you 306. 8 times 107, which would be 856. 16 times 112. And you don't have to do this every time, but I just want to do this first time. So it'd be 1,792. 13 times 117. It's 1,404. 7 times 122 will be 854. And 2 times 127 will be 254. And then 1 times 132 is 132. Now when you add all these together, it'll be 5,715. Because you're supposed to multiply these and then add them all together, which they show here. Now, it says this is our estimate of the sum of all data values. So at this point, we divide by the total number of values to get the approximate mean. So the total number of values, you would add up the frequencies here. That's what this denominator is. And this would be 50. So now we would take this 5,715 and divide by 50. And that would give us 114.3 degrees. And that's how we got this value here. So this would be our mean using those midpoints. Okay, now we move on to the next page. It says finding the mean of group data. We just went through that, so you can read that at your leisure. Now it says number 1, explain why the formula only gives an approximation to the mean, not the actual mean. We do not know what the actual numbers are. So we are making an educated guess. That's basically it in a nutshell. We don't know what the numbers are in the group frequency. We don't know the exact numbers, so we're making an educated guess when we're actually figuring off of the midpoint. Okay, number 2. It says the group frequency distribution provided illustrates the selling price of the 95 homes most recently sold in my town. Find the mean selling price. Okay, so first of all, we need to find the mean here. So basically, if you add these two together and divide by 2, so we'll have 101,000 plus 200,000 divided by 2, and it gives us 150,500. So I'm going to put this here. So this will be the midpoint. So it's 150,500. And if we look at the classes are going up by 100,000. So we would just add 100,000 here. Then next, this will be 350,500. All right, so these are all of our midpoints. Now again, after we get our midpoints, we have to multiply them by the frequency, and then add the values up and divide by the frequency. So 64 times 150,500. So that'll be, what's that, 9,632,000. Then we had 26 times 250,500. So it'd be 6,513,000. And then we would have 5 times 350,500. So it's 1,752,500. Now, we're supposed to add all of these up. All right. So that would give us 17,897,500. And it's divided by the frequency here. This would be 95 here. So that's 95. So 95 would be in our denominator. Oh. So when we divide that by 95, it'll give us approximately $188,395. They rounded to the nearest dollar. Okay, so now, so that takes care of using the mean with group frequency. Now it says here, many college courses have a grading system where different course activities make different contributions to the final grade. The idea is that things like tests typically have a bigger effect on a grade than attendance. Here's an example from a course I taught recently. They give all the weights here. Say homework is 50, four tests is 30 points each, final exam is 50 points, group project is 20 points, and attendance participation is 10 points. Okay, so now it says the size of the relative contribution for each activity is typically called a weight, and the overall grade is called a weighted mean. It turns out that we can calculate the weighted mean using the same steps we use to calculate the mean for group data. We just have to do some interpretation. Now it says the solved example 2. Turning mean for group data into a weighted mean. Okay, Tong is a student in the class using the grade structure just described. Her scores for each portion of the course are listed below. We got the homework average, the test scores, the final exam, group project, attendance, participation. If we're going to use the procedure for finding the mean for group data to calculate her overall grade, what role is played by the weights for each portion, and what role is played by her scores? Okay, now the solution. It says, in my view, the key to understanding this is points. Think of every single point in the course as one occurrence of something being awarded. When you see that homework counts for 50 points, you could think of it as 50 times that a point was ordered, which means it feels a lot like a frequency. So the fact that Tong has an 87% homework average is like getting 87% of a point 50 times, 50 different times. If that makes sense, then you get it. The bottom line, the weights act like frequency in a group frequency distribution, and the scores for each portion act like the midpoints of the classes. Okay, so with that being said, we're going to go down here to number 3. It says use the result of solved example 2 and the mean for group data formula to find Tong's average for the course. Okay, so basically here, homework was worth 50 points. So we'll take the 50 points times the 87%, which we'll change to a decimal. Okay, next, the test scores. Now remember, the test scores is worth 30 points, but it's for 4 test scores here. So what we would do, we'd take 30 times 0.91 plus 30 times 0.82 plus 30 times 0.86 plus 30 times 0.94. Okay, now, the next thing that we would do is we would look at the final exam score, which was 88%, and the points are 50. So it'd be 50 times 0.88. And then we will have a 92% for the group project. The group project is worth 20 points. So it'll be 20 times, let me see, that was 92%, 0.92. And then finally, the attendance is worth 10 points. So it'll be 10 times 100%, which is 1. And that's all divided by, we'll have 50 for the homework average. And then remember, it's 4 tests that are worth 30 points each, plus 50 for the final, plus 20 for the project, and then plus 10 for the attendance or class participation. So now we will put all this in our calculator, and it would give us 0.887, which is, the average would be 88.7%. That would be the average. 88.7%. We write that percent sign a little better. So 88.7%. Okay, now we move on to number 4. It says, what are the pros and cons of each of the measures of average we studied? And then we could look here at number 5. It says, look back at the description of the average college student in the opening paragraph. For each characteristic listed, write which measure of average you think was used. All right, so with number 4, the pros and cons of each of the measures of average. Okay, 1, mode is easy to find. That's a pro. So I'm going to list the pro first and the con second. It's easy to find, and then the con is that you could have no mode. That could be a con, because depending on the situation you're talking about, having no mode could actually be a problem. And of course, like I said, these are just general statement here. A pro is the mean gives the average of everything. It gives the average of everything. The con, which would be my second sentence here, is extreme values, either high values or low values, can alter the final outcome. The median, the pro is easy to find, and the con is does not take into account extreme values. Now I'll give you a for instance with that. Say you're trying to negotiate salaries at a firm, and say that in the past few years they hired a lot of new workers, and say that you're in the old group that still make a fairly decent salary, but the new workers, by them having such a low salary, they may outnumber you all, and their salary would be in the middle. So for instance, say it's a company that has 150 employees, and then say they hire in 80 new employees, and all 80 of them is just making $20,000. Whereas the ones that was already there, say they're at $70,000. So the company using the well, let me put it another way. Okay, that would be advantage for the worker. But looking at it the other way, say it's 150 employees and say 30 new people got hired in, and they all are just making 20,000, whereas the other workers is making the other 120 workers is making 70,000. Now the company could look at the sheet and look at the median and be like, oh, okay, our average is 70,000. But then if you're a worker making 20,000, you're like, wait a minute, no, that's not accurate. So that's one of the disadvantages there on that side, especially negotiating salaries. And then the mid-range is easy to find. That's the pro. The con is does not take all values into account. Okay, now, number 5. Okay, so we want to go back to the beginning. Now, they told us that the average college student was 20 years old, and that would be our mean. They say lives on campus, which would be our mode, then works off campus would also be a mode type. Female would be mode. Talks to parents every day would be mode as well. The family income will most likely be the median. Sleeps 6 hours would be the mean. $2,700 in credit card debt would be more like the median. And 21,000 in total debt would be the median. All right, now we're actually done with this activity here. So we're going to move on to section 4.6. Now, we're on lesson 4.6, which is on page 469. Our learning objectives, well, our title is Your Results May Vary. Our learning objectives is to compute measures of variation for a given data set, to interpret standard deviation for a data set, make meaningful comparison of standard deviation for 2 data sets, and analyze the procedure for computing standard deviation. It says research shows that there is only half as much variation in student achievement between schools as there is among classrooms in the same school. If you want your child to get the best education possible, it is actually more important to get them assigned to a great teacher than to a great school. Bill Gates. All right, now we come down here to the bottom. It says the simplest measure of variation that we'll study is the range. The range of a data set is the difference between the largest and smallest values in the set. So range is equal to largest value minus the smallest value. Okay, now it says the first list below is the weights of the dogs in the first picture, and the second is the weights of the dogs in the second picture. Find the mean and range for each list. Okay, so now we know, first of all, we'll go with the first picture. So the mean, we will have, 70 plus 73 plus 58 plus 60 all over 4. And then the range will be the largest value, which would be 73, minus the smallest value, which is 58. So that would give us 15. So the range is 15 pounds. And then now the mean, when you add all of this and divide it by 4, it'll be 65.3. So I put this a little too close. Let me change this up a little bit. So we have 70 plus 73 plus 58 plus 60 divided by 4. And that would equal to 65.3 pounds. Okay, so this is the mean, This is the range. Now we'll go to the second picture. So the mean, we'll add all of this up. Hold on. So we have 30 plus 85 plus 40 plus 125 plus 42 plus 75 plus 60 plus 55. And it's divided by 8. So now when we put this in our calculator, the mean actually would be 64 pounds. Now we want to do the range. The highest value here would be the 125. And the lowest value, it looks as though it's 30. So the range would be 95 pounds. So that took care of problem number 1. It says, describe what you notice about the range and mean for each group of dogs. The means are very close in value. The ranges are not close. They vary a lot. Okay, now why is the range somewhat limited as a measure of variation for the data set? Range only considers the largest and smallest values. That's what makes it limited, because the range only considers the largest and smallest values. On page 471, it says standard deviation. The range is a limited measure of variation because it ignores all the data except the highest and lowest values. And most of the values are similar, but there's just one unusually high value. The range will make it look like there's a lot more variation than there actually is. For this reason, we will next study standard deviation, which is a much more reliable and commonly used measure of variation. Standard deviation is a little tricky to compute. Eventually, we'll learn how to use technology to handle the computation, which will allow us to focus on interpretation. But first, we'll develop a procedure for computing standard deviation by hand. This turns out to be useful even if you never actually do compute it by hand, as it really helps you to understand what exactly standard deviation measures. This is a bit of an oversimplification, but it's still very useful in understanding what standard deviation is designed to measure. Standard deviation essentially describes the average distance that each data value is away from the mean. Read the description of standard deviation in italics above carefully again. Why does standard deviation provide a very reasonable way of describing how spread out a data set is? Since the mean is the center, finding values I should say finding how far away values are from the mean is exactly what you would typically think of when considering how spread out the values are. Now it says interpretation of standard deviation. Standard deviation that's large relative to the mean tells us that the data values vary pretty widely from the mean. A relatively small standard deviation means
You are currently the only person in this.
the most data values are clustered fairly close to the mean. Standard deviation comes in two delightful flavors, population and sample. As we saw in lesson 4.4, in many cases data are based not on every single member of a population, but rather a representative sample. When the standard deviation is computed for a data set derived from an entire population under study, it's called the population standard deviation. When it's based on data derived from a representative sample of a larger population, it's called the sample standard deviation. Computing standard deviation by hand is pretty complicated, and the truth is that we'll eventually rely on technology to do the computation. In fact, your instructor might have you do that right out the gate, and that's fine. But we feel like learning and using a formula is useful and that it will help you to understand what exactly standard deviation is measuring. So we're going to start there and learn how to use technology later in the lesson. In statistics, it's far more common to work with a sample than with an entire population. So we will develop a procedure for computing sample standard deviation. As we illustrate the procedure, try to pay special attention to the key ideas described in a solved example. After that, we'll ask you to think about what those key ideas really tell us. All right, now we have computing standard deviation. Okay, and this is the solved example. It says calculate the standard deviation for the weights of the dogs pictured in a lesson opener. Now it says first, step one, find the mean. In this case, we've already calculated the mean. It's 64 pounds. Key idea at its core, standard deviation is a comparison to the mean, so it makes perfect sense to start there. Subtract the mean from each data value. We find it helpful to set up a table to do standard deviation calculations. So basically, you find the mean and you subtract it from all of the data values, which we have here. Okay, now the key idea. We want standard deviation to be a measure of how far the data values are from the mean. So we should subtract to get the distance from the mean for each value. Now, our next step, we're going to square the differences. We'll just add another column to our table, squaring the results from the x minus the mean column, which we did. Now, the key idea, if we just find the average of all the distances from the mean, we'll always get 0, which isn't particularly enlightening. Try it. By squaring, we eliminate the signs to avoid that issue. Okay. Now we move on to the next page. We go to step 4. Add up the squares of the distances. This is just plain old addition, and we'll see why in a second. We add all those up. The key idea is to find the mean of the square distances. We'll add them up and divide by how many. So we start by adding them. So step 5, divide the sum by n minus 1, or 1 less than the number of data values. Okay, key idea. To get the actual mean of the square distances, we would divide by the number of values here. But when you have a sample of data values from a larger population, it's almost certain that there is less variation in the sample than in the overall population. So to account for that, we divide by n minus 1 rather than n, making the result a bit larger. Smart. Step 6, calculate the square root of the result from step 5. After this step, we have our standard deviation. The sample standard deviation for the dogs in the picture is 30.7 pounds or 30.70 pounds. The sample standard deviation for the dogs in the pictures, well, we got 30.7 pounds. Key idea, remember when we squared all the distances to get rid of the signs, this is where we're basically undoing that square. Okay, number 5 says, now let's see how you did in understanding the key ideas in the solved example. We set out to develop a measurement of how far, on average, the data values in the sample are from the mean. Based on the key idea, explain how we were able to accomplish that. Okay, now that is basically up to your interpretation based upon what you learned from the formula. So I would just leave that up to you to fill that in. Okay, and if you do have a question on it, you can ask me that question when we meet in class, or you can email me. Okay, number 6. It says use the procedure from the solved example to find the standard deviation for the weights of the 4 dogs in the first picture at the beginning of the lesson. Okay, now we need ourselves a table. So we had x, then we had x minus the mean, and then we had x minus the mean squared. So we had 70, 73, 58, and 60. Now we had the mean before from that problem. Our mean was 65.3. So we'll take 70 minus 65.3, which will give us 4.7. Now I'm not going to write this out for each one of them, but you know all of these will be minus the 65.3. So this will be 7.7, this will be negative 7.3, and negative 5.3. Now if we put these values in and square them, this will give us 22.09. This will give us 59.29. This will give us 53.29. And this will give us 28.09. So all we did was square these values here. Now we want to add all of these values up. 22.09 plus 59.29 plus 53.29 plus 28.09, which is equal to 162.76. So we'll take the 162.76 over 3, and that'll be approximately 54.25. Then we would take the square root. Oh, by the way, how we got the 3. Remember, the denominator is n minus 1. We have 4 values, so it was 4 minus 1, which gave us the 3. So the next thing we would do is take the square root of this 54.25, to give us approximately 7.37. So our standard deviation is approximately 7.37. That's our standard deviation. All right. Now we move on here to the next page. It says, carefully describe exactly what the standard deviation from the solved example And question 6, tell us about the dogs in the pictures. Include a comparison of the two standard deviations. Okay, basically what it tells us is how much the dogs' weight vary from their respective mean. Now they ask us to include a comparison of the two standard deviations. So we have 7.37 for the second one, and the first one, actually the first one is 7.37 and the second one is 30.70. So it says, what does it mean? It shows what we suspected earlier, that there is less variation with the first group of dogs than the second group of dogs. Okay, now it tells us that the following formulas summarize how to find sample standard deviation, and they also show how to find population standard deviation. For a population, the only difference in the procedure is dividing by the total number of data values rather than one less, like we did in finding a sample standard deviation. Now, the reason why we don't do the one less is because if we're using the whole population, then that lets us know that we could divide by the whole population instead of the standard, instead of subtracting one. Okay, so now we have what these values mean. X represents each data value. The X bar is the mean of the sample. The mu is the mean of the population. And then N is the number of data values in the sample. And capital N is the number of data values in a population. So if you notice here, really, these two are basically the same except for when you get to the denominator. That's where the big difference is in the values. Okay, now, they do show you here how to do the standard deviation on the TI calculator. You can look at that at your leisure. But now we're going to go here on page 476. It says a word on notation. We use a lowercase s to represent the sample standard deviation for a data set. The symbol XX SX is simply what's used on the calculator screen. Similarly, we use a lowercase Greek sigma to represent population standard deviation, not this here for the sigma x. Okay, so it says here, the table below shows the number of arrests in the United States for possession of marijuana in thousands for the years from 2008 to 2017. All data were gathered from the annual Uniform Crime Report published by the Federal Bureau of Investigation. Find the mean and sample standard deviation for the number of arrests, include units. All right, so we need to find the mean. Now, what I'm going to do here, I'm going to show you how to do this on the calculator because we found the mean before. So let's just type in these values. So I'm going to do this on the calculator. So we will have 620, 614, 541, 543, 503, 516, 575, 653, and 599. Okay, next, we go down here, we go to functions, we go to stat, click mean, and remember this is x2 now. So our mean here is 578.4. So we have put our mean is 578.4. Now, okay, so basically they want us to do the standard deviation as well. All right, so the standard deviation, if we go back to the previous page, standard deviation, and of course this is a sample. So we would have the x, the summation, so we have square root of the sum of the x minus the mean squared divided by n minus 1. Okay, now we can substitute in and do all of that, but we do have a feature on the calculator where we could click function, and you see where it says here standard deviation, and we could click x2, and that would give us the 50.5 if we round to 1 decimal place. So the standard deviation is 50.5. Okay, now I am going to, so you see how to put this in your calculator. So we had a mean 578.4, standard deviation is 50.5. So the mean is 578,400 arrests, and the standard deviation is about 50,500 arrests. Now, number 2, why was it appropriate to find sample standard deviation rather than population? That's because we only used a sampling of years, because we know that people have been getting arrested for marijuana for many more years than what's shown here. So now we go here, it says standard deviation is easiest to interpret when compared to the size of the mean. For example, a standard deviation of 10 in a data set with mean 20 indicates a much wider spread than the standard deviation of 10 in a data set with mean 200. To help make this easier, we can find the relative standard deviation, also known as the coefficient of variation. This number, usually denoted C of V, is the standard deviation divided by the mean. It's literally what percent of the mean the standard deviation is. Now, in symbols, the coefficient of variation, C of V, is equal to the standard deviation divided by the mean for the sample. C of V is the lowercase sigma divided by mu for the population data. It says find the coefficient of variation for the arrest data above. So we would do C of V is equal to the 50.5, which was our standard deviation, divided by the 578.4, which was our mean. Now that would give us approximately 0.087. So we could say the standard deviation is, if we change that to a percent, it'll be 8.7% of the mean. So the standard deviation is 8.7% of the mean. Okay, now we move on to our next page. It says here, do you think the standard deviation and coefficient of variation for the data set would be more likely to be used in an argument by someone who is in favor of legalizing marijuana or against? It can be used on both sides. You can argue since so few are arrested, why bother? Make it legal. But on the other side, you could say since so few are arrested, the campaign against it is working. That's why you have so few people getting arrested by it, because it's working. Okay, number 5, it says find the coefficient of variation for the 8 dogs from the solve example in the class portion. Compare it to your answer to question 3. What can you conclude? Okay, now in the solve portion, let's go back here. I think we did, yeah, we got 30.70 for the, let me do SV is equal to, the standard deviation was 30.7 or 30.70 divided by the mean, which is 64. Put that in our calculator, be 0.48. So it's telling us that the standard deviation is 48% of the mean. Which shows the dog's weight varies significantly. I'm going to give myself enough space here. Significantly more than marijuana arrests. Okay, now it says for questions 6 to 8, identify the data set that is likely to have a larger standard deviation. Make sure you explain your reasoning, like with sentences and stuff. No calculations necessary. Okay, data set 1, then we add data set 2. Now we want to say we'll have the larger standard deviation. If you look here, the lowest value is 2, and the highest value is 33. Here, the lowest value is 10, and the highest value is 16. Their data sets have more values that are closer. So I would suspect that it'll be data set 2. The values in set 1 are all within 6 units of each other. while in data set 2, they are very spread out. Okay, now we come here to number 7. It says data set 1, 40-yard dash times for starting running backs in the NFL. Data set 2, 40-yard dash times for every student in the math class. I would say data set 2, and the reason is data set 1 would expect pro football running backs to be close to the same speed. In data set 2, there would be more variation because of the different fitness levels. Okay, now we move on to the last page of 4-6. Okay, we come here to problem number 8. It says data set 1, average monthly temperature in Chicago. Data set 2, average monthly high temperature in Los Angeles. All right. Now they ask us which one do we think will vary more. So in this case, it'll be data set 1. Chicago has more extreme temperatures than Los Angeles. So it would vary more. Okay, number 9. It says the professor has 2 sections of Math 115 this semester. The 8:30 a.m. class has a mean score of 74% with a standard deviation of 3.6%. The 2 p.m. class also has a mean score of 74%, but a standard deviation of 19.2%. What can we conclude about the student averages in these 2 sections? All right. Based upon the standard deviation and the mean score, we can see that class 1 has a low coefficient of variation, and the scores would be close to each other. Class 2 has a high coefficient of variation, and the scores will be more spread out So now number 10, in the technology portion of of the portfolio, you'll be analyzing the heights of every student. Okay, so we're not going to do number 10. So we are actually finished with section 4-6. So we're actually done with 4-5 and 4-6. If you have any questions, feel free to email me. Have a wonderful day.